And I are doing module 10, practice problems, and we've done 1 through 6. This video, we're going to do number 7. Number 7 is pretty complicated, and it's going to take us a while to do it. There's a lot of steps. So, Martin, you ready to read it to us?
A chemist makes a stock solution of NaOH by dissolving 950.0 grams in enough water to make 2.00 liters of solution. If later on he wants to use this stock solution to make 100.0 milliliters of 0.10 molarity NaOH, what would he need to do?
Okay, so the first part of this problem, we have to figure out what is the concentration of this solution. Then we're going to do a dilution equation, which we did in problem number 6, and that's going to look like this. Okay, we're going to use the dilution equation to, not the diluted equation, dilution equation to find that. But first, we don't know what the M1 is, so how can we find that out? So molarity, as we know, is the number of moles per the number of liters. We don't know the number of moles, but we do know the number of grams. So guess what we get to do, chemistry students? We get to figure out the number of moles. So what's the molecular weight of NaOH?
Okay. Na is 23.0. We know oxygen and hydrogen.
Okay, so we get 0, 7, 10, 40.01. We can use the hundredths place. So it's 40.0 grams per mole. Okay, so we're going to multiply 950.0 grams times 1 mole per 40.0 grams and find out how many moles we have. So please divide 950 by 40 and give it to me with 3 significant digits.
Divided by 40. Okay, 23.8.
23.8 moles. Okay. Now we know we have 2.00 liters. So to find the molarity, the first molarity, molarity 1 is going to equal moles, 23.8, divided by liters, which is 2.00. So we can report the M1 to 3 decimal places. So what's that going to look like? We can do this? Actually, this is so simple, I'm not even going to bother using a calculator. 1, 1, 9. So it's 11.9 is the concentration of this. Okay, so that's M1. Do we know V1?
I think so.
We do. It's this, 2.0 liters, right? Do we know M2?
Yeah.
What don't we know?
V2.
Oh, wait a minute. I'm wrong. I don't know that we do know volume. What's volume? Tell me, read the problem again. No. He has 2 liters of solution, but we don't know how much. Okay, so he has 2 liters of solution. We don't actually know how much of it he's going to use. We don't know the volume. Okay, he has 2 liters altogether, but we don't know how much he's going to actually use to make this concentration and this volume. So this is V2. This is M2. So what we do not know is V1. Okay, we know how much he has, but we don't know how much he's going to use to make this of this stock solution. Does this make sense to you?
Yeah.
So to find volume 1, it's going to be M2V2 over M1. So M2, 0.10 molarity times volume 2, 100.0 milliliters divided by 11.9 molarity. Okay, so do this math. This will give us answer in milliliters, which is fine.
Okay, how many significant figures? 3?
3.
Okay,
No.
so
Wait.
0.840.
Only 2. We can only use 2.
So
because we only have 2
then.
here. What is it?
0.8.
That's only 1.
4.
That's 2. So the volume 0.84, and that's milliliters. Okay, I never did convert to liters, so that's fine. So it's not going to use very much. Okay.
Okay.
It's a really small amount to get 100 milliliters. Look at the dilution difference, though. This is very concentrated. Look at this, 11.9 to this, which is not even a tenth of a mole per liter.
Wow.
Okay. So that's it for number 7. Any questions on that?
No.
Let's move right on to number 8. Well, we're still here.
Okay. A chemist needs to know the concentration of some NaO.
Number 8.
Oh. A chemist reacts 50.0 milliliters of 4.5 molarity carbonic acid, which is H2CO3, with excess potassium hydroxide. How many grams of potassium carbonate are produced?
Okay, so they don't tell me the formula for potassium hydroxide. Okay, so it's going to be
hydroxide.
Yeah, it's going to be OH. So it's going to be some kind of K. I think it's just KOH.
Yeah.
All right. So we've got okay. So how are we going to figure this out? First, let's set up our equation, our chemical equation. This is an acid base yields water, salt, and a water problem. We have H2CO3 plus KOH yields something and water. What's our salt going to look like?
CO3, yeah.
Right. So how many? What's our numbers going to look like? Because it's not just going to. Well, look, we've got 2 H's to find, so we're going to have at least 2 of these. This is a single plus. This is a 2 negative, so it's going to be K2CO3, right? Martin?
Yeah, I am paying attention.
Good. So it's K2CO3. Right? We need at least 2 oxygens over there. Makes sense. Now it's 4, 4, 1, 2. Okay? Everything's balanced.
Yeah.
Look good? So, just a minute. Or even, of course, write that down. Okay. So what is the amount of moles of carbonic acid here to moles of potassium carbonate?
Okay, so
in my balanced equation.
It's 1 to 1.
That's right, 1 to 1. Okay, so I don't know how many moles that I use here. Okay, but I do know the concentration, so I can figure out the moles. Let's look over here. So we've got 50 milliliters at 4.5 molarity. Now molarity equals the number of moles per the number of liters. Okay, so let's put this into liters. 1, 2, 3. So the molarity 4.5 So if we want to find the number of moles, we're going to say the number of moles is equal to what? The molarity times the number of liters.
Okay.
Right? That's how we do the
We
math.
have molarity. And
Yes,
liters.
we do. We
Okay.
have all those things. So the number of moles is going to be 4.5 times the number of liters, which is 0.05.
Liters. 0.225.
Sorry?
0.225.
You multiply 4.5 times
0.05, yes.
0.225. Okay, so we're going to be limited to
2.
2, so we're going to say 0.23.
Okay.
0.23 moles. Okay. So what does that tell us? How many moles
Oh, yeah,
of potassium carbonate are produced then?
Right. So now we just...
How many moles of, if we're using 0.23 moles of carbonic acid or whatever it is. Yeah, carbonic acid. So that's 1 mole. And we get 1 mole of potassium carbonate.
Mm-hmm.
So now what? We need to know how many grams. Okay. So let's find out the molecular. We've got 0.23 moles.
Yes.
What's that grams? So K, 2. How much?
Potassium is 39.1.
39.1. And carbon, I think it's 12.0.
40.1.
40.1.
Wait, that's calcium.
Yeah.
Carbon is 12.0.
12.0 and 3 oxygen is going to be 48.0. Or 16. So 1, 10, 19, 4, 5, 9. 99.1 grams per mole, right?
Yeah.
Okay, how many moles do we have? Martin.
How many moles? 0.23. That's not a lot of
Oh,
moles.
sorry, I only used 1K. Whoops. You see what I mean?
Yeah.
I should have done 2 of these. Okay, 2.
Okay.
Okay, so it's actually 138.2 grams per mole. And we don't have to worry about significant figures here. We have to worry about precision. We want to continue being precise to the 10th place. So 138.2 grams per mole. Now we know how many moles we have. So we're going to multiply 138.2 grams per mole times the number of moles, and that will give us the number of grams. I always love it when my math units work out. That means I've set my problem up correctly. We're going to end up with grams. Yay, grams. All right, do the math, please. Multiply.
138.1.
No, 0.2. Sorry.
0.2
Times 0.23.
0.23 is 31.786.
Okay, and that would be grams. So we can only use 2 significant digits.
So 32.
32 grams. Okay, so how many grams of potassium carbonate? 32 grams. Yes. All right, we're going to pause here.